In this lecture, we talk about quicksort algorithm, which is a divide and conquer type of algorithm. What it means is it progressively divides the given array into smaller arrays where quicksort can be applied on each of the subarrays progressively. This relies on identifying a pivot element. The pivot element can be fixed either at the beginning of the array or at the end of the array or in the middle, or for that matter we can fix any random element as pivot element also. But usually in the usual practice, people will take either the last one or the first one, or sometimes the middle one. Now once we take the pivot element, this algorithm tries to move the elements, identify the elements which are less than the pivot element and places them on the left hand side of the pivot element. And the elements which are greater than the pivot element will be moved to the right side of the pivot element. And once they are arranged, the pivot element will be shifted to the corresponding location. This is one cycle. Once this cycle is complete, at the end of the first cycle, the pivot element reaches its corresponding location, and all the elements to the left of the pivot element will be less than that, and all the elements which are to the right of the pivot element are greater than that. So that now on the subarray, which is on the left side of the pivot element, again quicksort can be applied. Similarly, on the subarray, which is to the right of the pivot element, quicksort algorithm can be applied. In this lecture, we talk about quicksort algorithm, which is a divide and conquer type of algorithm. What it means is it progressively divides the given array into smaller arrays where quicksort can be applied on each of the subarrays progressively. This relies on identifying a pivot element. The pivot element can be fixed either at the beginning of the array or at the end of the array or in the middle, or for that matter we can fix any random element as pivot element also. But usually in the usual practice, people will take either the last one or the first one, or sometimes the middle one. Now once we take the pivot element, this algorithm tries to move the elements, identify the elements which are less than the pivot element and places them on the left hand side of the pivot element. And the elements which are greater than the pivot element will be moved to the right side of the pivot element. And once they are arranged, the pivot element will be shifted to the corresponding location. This is one cycle. Once the cycle is complete, at the end of the first cycle, the pivot element reaches its corresponding location, and all the elements to the left of the pivot element will be less than that, and all the elements which are to the right of the pivot element are greater than that. So that now on the subarray, which is on the left side of the pivot element, again quicksort can be applied. Similarly, on the subarray, which is to the right of the pivot element, quicksort algorithm can be applied. Now we will take an example consisting of 9 elements in the form of an array, and we'll fix the leftmost element as the pivot element. So in this case 34 is taken as pivot element, and we'll try to arrange as per the quicksort. As we have seen, we move from the pivot element to the right side, keep on moving to the right side until an element which is greater than the pivot element is encountered. Similarly, we'll start from the rightmost end. Since we have taken the pivot element on the leftmost, we will also start an index from the rightmost end, and we will traverse the array until we reach an element which is less than the pivot element. So in this case, if we keep on moving from the pivot element from left to right, 26 is less than 34, so move on to 1. 1 is less than 34, so move on to 45, which is greater than 34. So 45 is a least greater element than 34, which is to the immediate right of 34. Similarly, another index starts at the right end. 27 is less than 34, so that element is identified. Now in this case, 45 and 27 are the elements which are identified, which are greater than 34 and less than 34. Once we identify these two elements, we swap them, swap the locations of 27 and 45. So once they are swapped, the arranged array is depicted in the second forms. Right. And once this is done, again from those locations where they have been swapped, from those locations, again indexes will keep on moving until we find out an element which is greater than 34 from left to right and less than 34 from right to left. So in this case, after 27, 18 is the element which is less than 34. So move on. 78 is the next element which is greater than 34. So stop there. And the right index starts from at 89, which is greater than 34. So move on. So 12 is the next element from left, right to left, which is less than 34. Stop. So in this iteration, 78 and 12 are the elements which are greater than 34 and less than 34. You can swap them. Swap the locations 12 and 78 after swapping. Once this is done, again if we want to move the indexes from right to left and left to right, the indexes crosses each other at that location. So this is a stopping point for this cycle. Yeah, once the first cycle is complete, the pivot element 34 can be shifted now to the location where the 12 is present, because that is a location where all the elements which are left side of 12 are less than 34, and the elements which are after that are greater than 34. So what we do is we'll shift or swap 12 with 34, so that 34 reaches its location, and the left subarray of 34 consisting of the elements which are less than 34, and the right subarray of 34 consists of elements which are greater than 34. So this completes one cycle where the pivot element has been shifted. 34 has found its place in the sorting. Now, if we concentrate only on the left subarray of 34, again we can apply quicksort algorithm on this subarray consisting of 12, 26, 1, 27 and 18 only. That is one left subarray. And the right subarray is 78, 89, 45. This is another subarray where we can concentrate on quicksort only on that subarray. Again, if we focus on the left subarray consisting of 12, 1, 26, 27, 18, again we'll take the pivot element as 12 for the left subarray. Once we take the 12 as the pivot element, now again we proceed to the right of it from left to right, and once we encounter an element which is greater than 12, we'll stop there. So 26 is greater than 12, we'll stop there, and move from right to left. That means 18, 27. 18 is not less than 12, 27 is not less than 12, 1 is less than 12. So when we encounter an element which is less than 12 from right to left, we encounter an element which is greater than 12 from left to right. So 26 and 1 are the elements which are identified, and they are swapped. They need to be swapped. Once they are swapped, again if we keep on increase the indexes, they cross each other. So we stop there, and we found out the location for the pivot element again in the second cycle for the left subarray. So again we have to swap the locations of 1 and 12, and 12 reaches its location in the left subarray, dividing it again into smaller subarrays consisting of 1 on the left side of 12, 26, 27, 18 on the right side of the 12. So we got two more subarrays in this case. Now 12 has found its place, 34 has found its place, and these two are dividing the array into subarrays consisting of subarray consisting of only single element 1, subarray consisting of 26, 27, 18, subarray consisting of 78, 45, and 89. So if we focus on the subarray consisting of only one element, there is nothing to be sorted. We can stop quicksort on that subarray. Now if we focus on the subarray consisting of 26, 27, 18, and we pick up the leftmost element 26 as the pivot element here, again if we keep on moving, 27 is greater than 26, stop there, and from right to left, right to left, 18 is smaller than 26, so that is identified. Again they have to be swapped, 18 and 27 are swapped, and once they are swapped, the location, again if we continue this, the indexes will cross each other, so we'll swap 26 with 18. So again 26 has found its place, and it is dividing the subarrays into 18 and 27 of individual elements. So this completes the left part of 34, quicksort of left part of 34 completely, because each of the subarrays consisting of single elements. Now we will focus on the subarray which is to the right of 34, so 78, 45, and 89. Again we will take 78 as a pivot element, 45 is less than 78, 89 is the element which is greater than that. Again we need to swap 45 and 78, so that 78 found its place. Now once 78 is found its place, again it is subdividing the array into 45 in one subarray and 89 as one point location. So by this time all the pivot elements have reached their locations, and the subarrays consisting of only single elements, and they need not be sorted. So this completes the sorting of the entire array. Now the entire process can be depicted in the form of a pseudocode or an algorithmic process. If you observe here, the function quicksort takes the input as an array, and first and last elements are the inputs. Now if as long as the first is less than last, this algorithm progressively progresses to partition into two parts, where again quicksort can be applied on the left part consisting of array first and location -1, where location is the point where the pivot element will be swapped. Once the pivot element is swapped, you observe that the left side is one subarray and right side is one subarray. So array first and location -1 is a left subarray. Again quicksort can be applied recursively on that, and array location +1 and last is another subarray on which again quicksort can be applied there. Now partition can be done again in a separate functionality, is depicted in the separate functionality here. Partition consisting of array first, last, and location. So left is taken as the pivot element here, left is equal to first, and the right is equal to right -1, last +1 is taken as the index. Pivot is taken as L of first, the first element is taken as a pivot, and progressively we keep on observe from left to right until L of left is greater than or equal to pivot, and similarly right is decreased from right -1 until L of right is less than pivot. Once you observe that, then if left is less than right, then swap. So once this process is done, location is shifted to right, and swap the left and right at the point of time. That means the pivot element is shifted to this corresponding location. Once we do that, partition is complete. Once partition is complete, again we'll go back and apply the quicksort on the remaining subarrays. This is how the algorithm progresses recursively on the subarrays to sort the elements. If we implement this algorithm through any programming language, we can analyze the algorithm for the best case, worst case, and special cases. When it comes to the best case, interestingly here, when the array is sorted in the completely sorted form, either ascending or descending, it is not the best case, it is the worst case, and the complexity is more. Why? Because every element has to be compared with all the other elements. In this case, just take an example with a pen and paper and try to work out how things will go if the given array is completely sorted. And the best case occurs when the numbers are randomly uh, placed in the array, more or less. Why? Because quickly it identifies its location and sorts. And one more special case is when all the elements are same. Again, this algorithm performs very badly because comparison has to be done with all the other elements also. And when the array consisting of duplicate elements, say for example, if array consists of 100 elements where one element is repeating 4 times, another element is repeating 7 times, another element is 10 times, like that. In this case, some kind of modifications can be done for this algorithm, or some kind of additional data structures or additional arrays can also be used to place the elements, can also be used so that the performance of the algorithm can be improved. Overall, this is a very good algorithm where, in general, without requiring any additional space, we can quickly complete the sorting process.